This presentation looks at energy conversion. And you probably know that one form of energy can be converted into another. So, for example, chemical energy in batteries or fuel can be converted into electrical energy, which can be converted into kinetic energy, or it can be converted into chemical energy directly. Or it can be converted into directly into electricity. And that can be used for lighting or use of household instruments, or chemical energy in food can be converted into energy used to do work. And in this presentation, we're going to describe the nature, form, and conversion of energy. It's going to include the definition, what energy is, kinetic energy, potential energy, and units of measurement. So we're going to have a joule, megajoule, terajoule, gigajoule, watt, megawatt, kilowatt hour. Notice that watt is a measure of power. In other words, the rate at which work is done. And then types of energy: solar, heat, light, electrical, nuclear, chemical. And examples of energy conversion. And briefly talk about renewable and non-renewable resources. Explain the importance of energy to a society, what we use energy for. Okay, so energy then is the ability to do work. And there are different forms of energy, such as kinetic, which is the energy of motion. It depends on the person. Motion, therefore. Amount depends on speed and mass. So an example would be a person running. Potential energy is energy of an object to its position. Quite often gravitate due to gravity. So gravitational potential energy depends on weight and height. We can think also of potential energy due to pulling back an arrow. As when once you release the string, the arrow will shoot forward. Then you have thermal energy. This is due to heat. The total amount of energy of particles that make up an object. An object, say a cup of water, will always have a heat content as the particles are moving, and that's thermal energy. So steam, for example, will have a lot of thermal energy, and we can use that thermal energy to make electricity, for example. And then you have chemical energy, the energy of a compound that changes as its atoms are rearranged. So the arrangement of atoms in a molecule provide energy, and the bonds can be rearranged and broken and so on, and that can release energy. And then we have power. It's a quantity that measures the rate at which work is done. So power equals work over time. And in general, doing the same amount of work but in less time requires more power. So, for example, if you run up a flight of stairs, you'll do the same amount of work, but if you run up, you do it in less time, and therefore it requires more power. And therefore you get tired out faster. And then certain units for joule. You can learn all of these, but ones of importance are kilojoule, which is 10 to the 3 joules, megajoule, 10 to the 6 joules, gigajoule, 10 to the 9, and terajoule, 10 to the 12. and then kilowatt hours. What are kilowatt hours? This is what you are built for. Really, it's the number of watts you use over a period of time. So you might have an appliance which uses, say, 80 watts. If you have that appliance on for one hour, that would be 80 watt hours. Quite often, since we use a lot of electricity in a month, rather than using watts, we use kilowatts, which is a kilowatt is 1,000 watts. So energy then is measured in joules, and again, 1,000 joules is a kilojoule, 1,000,000 joules is a megajoule, 1,000,000,000,000 joules is a gigajoule, and a quadrillion is a terajoule. Example, a light bulb, quite often we use, can be 40 or 100 watt. And energy used by a 100 watt bulb in 24 hours is 8.6 megajoules, or 2.4 kilowatt hours. And average UK electrical energy consumption is 16 kilowatt hours per person, or 58 megajoules per person per day. So the UK population, for example, is 60 million, basically. So 60 times 10 to the 6, it gives 40 gigawatts. And different countries, of course, have different energy consumptions. So this one, the world uses 23,398 gigawatt hours per year. Of this, 7,500,000 comes from China. But China has a large population, so the watts per person is kind of 527. Whereas the United States, with a much smaller population, uses 3,989,566 gigawatt hours. So per person, this is much, much higher. And India's, of course, is very low, although it has a third highest energy consumption, 107. Notice Canada, per person, has a very high per capita use. And this is because electricity is very cheap in Canada. And that's because it has a lot of hydroelectric power. So considering a country such as Jamaica, we have a consumption of, 3,025 kilowatt hours per year, gigawatt hours per year, or 177 watt hours per person. So Jamaica, in fact, uses more electricity per person than, say, India, which is 107. And we have different forms of electricity generation. We have hydroelectric power, thermoelectric, nuclear power. We have wind, solar, thermoelectric from coal, thermoelectric from gas, and then PCH, which is kind of mini hydroelectric station. And different energy forms have different efficiencies. So notice diesel engines are between 30 to 40% efficient. A gas turbine is also a similar thing. A steam turbine, a bit more efficient. Later on, we'll learn about gas turbines and steam turbines. A gas turbine turns through the burning of gas, whereas a steam turbine turns by the turning of is by the movement of steam. Then have nuclear, which is between 30 to 40. And combined gas steam turbines, these are more efficient. And then fuel cells are also more efficient. And examples of renewable energy are solar, hydropower, biomass, geothermal, and wind. We'll look at these in more detail later. Non-renewables are oil, coal, nuclear, and natural gas. And then world energy consumption by sector. You can see that more than half of the energy generated is used for industry, and the next highest is for transportation, followed by residential, and then commercial. So, and then how much of this is on different forms of energy? We can see that transportation is largely petroleum, a small amount coal, and then a small amount natural gas. And this is probably this might be worldwide. I think in many countries, for example, coal is no longer used. Well, it was in 1950, sorry. So yeah, this could well be UK, I think, using British thermal units. So coal was banned use of coal was stopped in England, kind of in the 1960s. But nearly all of it is petroleum, a small amount natural gas, and then a small amount renewable energy, probably mainly biogas. For industries, notice in 1950 again there was a heavy use of coal and small amounts of renewable energy. Renewable energy increased massively between 2050 and 2018. Residential also significant increase in renewables and no longer use of coal. Coal isn't used again because of its harm to the environment. And in terms of India, so maybe this refers to India. Although India still uses some amount of coal, perhaps for industrial, residential, and commercial generation of electricity. So coal is the main generation. Then you have hydroelectricity and other renewables, or by nuclear and diesel. So then energy demand, again, coal is a major factor, followed by oil, followed by natural gas. And notice between 2000 and 2013, the percentage of biomass, in fact, decreased. Probably this was because the energy demand increased and the country was unable to keep pace with the demand, so had to use fossil fuels in order to meet energy demand, because fossil fuels is the easiest way of generating electricity. So you can see between 2000 and 2013, use of energy increased massively. And that's why there was an increase in use of coal. Amount of oils perhaps slightly decreased. Significant increase in natural gas, but that's more environmentally friendly. More use of electricity. Probably bioenergy has stayed more or less the same. Of buildings, much more bioenergy use. For transport, nearly all oil. And agriculture, nearly all oil and electricity. And again, if you look at electricity generation, has increased rapidly. And again, the use of coal has increased significantly. But what is energy used for at home? It's mainly for heating, cooling, water heaters, humidifiers and dehumidifiers, lighting, washers and dryers, entertainment, refrigerators, ceiling fans, ovens, and dishwashers. This is probably from, well, again, it's probably India, yes. Which is surprising. But how energy is used at home, we need to know it can be used for heating, cooling, water heaters and humidifiers, lighting, washer dryers, entertainment. At least know some of the uses of electricity at home. And this more or less completes this presentation.